So, how many of you know Chargebee? That's okay. And so what we do is we are a billing provider. We take out the complexities of billing, uh, tax invoicing, payments, reconciliation for primarily for subscription businesses. Our customers include SaaS companies, IoT, e-commerce, subscription boxes like Soylent and Craftsy and such. Digital media, we have few services companies, few non-profits, newsletters, and all other long tail businesses. So this sort of gives you an overview of what modules or services that we provide. It's basically invoices, subscription management, credit notes, taxes, all your billing, how do you collect your dunning and other things. The slide is a little old. We push all this data into, not only do we collect and do all the subscription management, we also take care of collecting, pushing that information into your accounting system, pushing the information into your CRM systems, and take care of. It's more like an ERP where we sit in the center. We push a lot of data to other tools that you use. We have around more than 10K customers. When I said customers, it's basically businesses. Should be around 53 countries, might be even more. We have raised around 38 million in venture capital, all Tier A VCs, Axel, Tiger. You might have known or invested in Flipkart, Insights, Shopify, and SteadView. Recently we raised it from them with other people. We have 4 global offices. One in Chennai is a base where we have all our technology team. We have 2 offices in US, 1 office in Amsterdam, and I think one or 2 people in Australia. We have more than 300 employees as of now. I was in Zoho for 13 years, one of the early employees of Zoho. Worked in a lot of products during the 13 years. So initially, they were into network management as a platform. I was involved in the rapid application development tool. Then we moved into an OEM framework. Then into point products, a lot of point products. I think Zoho had around 70 plus products at the time. Then during 2005, 2006, there was a shift to SaaS. You had all your writer and docs and everything else done. That's the time when I also moved to that what you call division. Worked there. 2011, myself and 2 other co-founders from Zoho and a friend of 4 of us started Chargebee. Before we get started, right? This was the architecture that we started off with at 2011. The first version of it when in production was this. We had 2 servers, we had a DB, no complications, nothing. Pretty simple. Okay, and we had, I think, linked it to a PagerDuty alerting system. No complex. We did not even have S3 or CloudFront. We knew that, but just didn't do it. Just simple system. This was a nice way to you onboard anybody, right? Any new developer, just 2 minutes. Draw it. This is it. Not much difference from your local development to production. Just that it is 2 servers. Okay, I'm just starting off with the storage. We have been quite, I would say, conservative in terms of storage because that's a tougher part of it. Always, we use MySQL RDS as the primary database. That's our primary thing, and then we started using S3 for static content and all the CloudFront, funded by CloudFront and everything else. Standard again. We started off using DynamoDB for unstructured content like email. Just wanted to we things that you could have used in S3, but we wanted to use that because it gave a more consistent latency. So we started off with that. Now we are started using it more for configurations, more complex configurations, that things that not requiring too much querying for things. Then we started using Postgre for RDS for analytics, primarily because it has more similarities with Redshift. And we didn't initially go immediately with Redshift because the cost was on the higher side. Because we are a SaaS provider, we need to also think about the costing side of it, how much it's going to cost, and there are some limitations in terms of the number of connections that you can open in Redshift. So we had those things, thinking about a lot of customers in, and then you need to communicate and everything else. So that's the reason we initially went with Postgre. Now we are we are planning to move to Redshift for at least for the enterprise customers, large customers. We are also dabbling with Google BigQuery recently for internal data lake. This is our storage. So maybe now I'll get to the scaling part steps. So okay, the first step we did was to scale, was to start off with master slave. Pretty easy, again, it's easy to do it. And then we did things that we some of the jobs that are heavier, like reporting jobs, we ensure that it ran only if the slave is available and everything else. For some of the queries, list queries and all, we ensure that it will hit the slave if the replication lag was in acceptable limits. Otherwise, it will switch to master. So we had those things, and we ensure that we can have multiple slaves, and if a slave goes, CPU goes up or something else, we check the alarm and then ensure that we don't use that slave. So we built in that layer into the querying thing. And also basically some of the indexes, right? So slave is heavily indexed. We don't do that indexing in master. So slave is heavily indexed. So any query flow, just index the slave. The next step we did was to sort of we realized that some modules, right, some are more heavily used, have a different access pattern and different usage pattern than other things. So we vertically sharded it. So we do have a common hot thing where common metadata is stored, but everything else is sort of vertically sharded. And obviously all the microservices databases are separated out. Analytics is separated out. You have a vertical shard, you don't have it. That's the second step we did. The third step we did was obviously the horizontal scarring. As you have more customers and everything else, we sharded them horizontally. For us, a site is basically a logical grouping of the customer data with the configurations. A site is associated with a set of shards, all the microservices and everything else. So you can have multiple shards, and a site is it is a MS to N relationship between the site to the shard mapping, and yeah. So the provisioning happens during sign up. So you're able to do all these shifts, right, from slaves to the vertical and the horizontal sharding, because we had an ORM query layer that we built that ensured that. So one another thing that we did was we added all our tables, all our merchant specific data will have a site ID column in the table. So that helped us to ensure that our ORM query layer, we built the whole framework to ensure that the routing happens there, both in terms of picking the slave or picking the master, whatever it is, based on the context of the action. So that layer was built here, and that helped us to ensure that we are able to do all the scaling without having to go and screw up, having to go and rework on the business logic. Yeah. And as you can see, right, since we'll have a lot of shards and a lot of slaves and everything else, and etc. Different microservices and everything else, we have built a tool to ensure that we are able to pick the shards to run the migration, test the migration, and everything else. Initially, we did it with scripts and then just didn't scale, and we didn't have the right roles and everything else to be done. So, just build a tool around that. So, whatever this is all about, it's not about our S3. These two have that model. Like, so, both Postgre and MySQL follow this slave and vertical and MS10 shards. So we'll be able to sort of pick. It's not like a set of sites have a separate set of databases and everything else. It's just that it's in a MS10 and we can pick. Okay, hey, this for this microservice, this shard is good enough. We can just use it for all our sites. So that type of thing. So that whole logic is managed by the query layer. And the query layers also ensures that the sort of the filtering is done at a site level. You cannot cross the site. There's a data isolation that is happening because it automatically adds the necessary conditions and everything else into the query, so it doesn't allow you to shift. Even if you make a mistake in terms of query, it just doesn't. You don't screw up your customer state. So what generally happen is, if by mistake we do a role, some role, some data alone to be shown, some developer wrote a code that extends that, right? It might let you. We don't let other customers' data to be seen. Max, you want to see your merchant's data. So the next bigger problem next thing that we are looking at is multi-region, because that's something that any global SaaS player will have to someday or other think about it. See, there are countries are coming up with some regulations and everything else where everybody wants to store their data in their particular country, especially after the fiasco of US surveillance. So some of our customers are somebody like BMW and everybody else want their data to be present in EU. There are Australian rules that are coming up saying that their data should be present, their customer data to be present in, and you have Indian government also looking at some rules around that. So just storage is the toughest part, as we all know, right? It's if you need to think about how do I enable a global company which also has to comply to the regulations, at the same time generate reports. So the complexity of having to do that is something that we are working on. So AWS provides different regions, but they have everything within that region. So if you have something around Alarm or CloudWatch or anything else, it all works within that region. So you don't have a dashboard that is cross-region, which means that you need to build the complete thing that is cross-region things. So just adds a lot of complexity to the whatever challenge we're already facing.
Then each client will be located in a specific location.
But that's the step one that we're going, like AWS we can offer, but assume that the client itself is a global company. Okay, so that's the first step we're going to say. We're going to say, like AWS, this is the region, we have things in the region, you pick your region. That's the first step you're going to do. Just afraid about bigger enterprises coming in saying that, hey, I don't want to write code to do that. You take care of all the things, just give me one layer where I send the customer the data, and then you take care of placing that customer in that particular region. But my reports, my queries and all should. So that's just the complication that we are cognizant of. So first step we are going to do is exactly what you said. It's going to be per region. But the problem in that thing is, anyway, your monitoring and your things should work over that. Your deployment should work across regions. So it's not that we don't have. So AWS, all this systems are all per region. So you need to build something layer completely over it for it to work. Before I jump something else, so we being a subscription business, right? B2B to C company. one of the challenges is you will have customers or merchants or with different sizes, right? So there'll be somebody like Philo or thing Freshdesk. A lot of you would know, right? We'll have a lot of customers, and you will have e-commerce companies where they might run a marketing campaign massively on a particular day, right? So we'll have a lot of load. So in a B2B2C model, one of the tough problems is to ensure the quality of service, right? You could have a lot of load on a particular day on a particular customer. The idea is you should be able to serve them without affecting other customers, other merchants, because they will also be critical. That's a one complexity that has to be handled. Yes, that's especially true for us in terms of the scheduled jobs, because ours is primarily a subscription, right? So everything is, a lot of things is more than a lot of APIs will be there, but more than that, you know, a lot of scheduled jobs. So we may be running around 3 million scheduled jobs. All some of them are simple, some of them quite complex. How do you manage them? So if some customers schedule a lot of jobs at a particular time, so if everything gets picked, then you will be running only for that particular customer, right? Other customers get starved. But at the same time, you cannot do sort of scaling, because your storage is not going to scale. You cannot do app scale. You cannot do auto scale at the app level because your storage is not going to scale. So we have our own custom job scheduling framework. So the basic model is within a server you have multiple pickers, and each picker will have a n execution, such that we'll have multiple servers, again M to N model. The picker is in between because it ensures that too much load is not put on the server for fetching the data. Then it's all executed. This model sort of helps us to ensure that, you know, if, and we will have throttling at some pickers will have throttling enabled, some pickers will not, and everything else around that. This ensures that, you know, we are able to provide the same level of quality of service based on the load. If some customers are on high load, then they may be delayed, but doesn't affect other customers' data around it. This same case for queues or anything else we do, because we have one queue, and then a particular customer's data just gets added to a lot to the queue, then you'll be processing only that customer's data. As I said, again, you can't do vertical, you can't do a auto scale because we have a storage that doesn't scale like that. So that's something that's always been challenging. So for every design is something that we take into mind and build things around that. So just because we have, as you said, right, there's a lot of complications in terms of how we run and around that. So we built our own sort of a tool that helps us to manage all the servers and the profiles and everything else, to ensure that we are able to appropriately say that, okay, hey, reporting jobs, there can be only 10 jobs reporting or some X jobs running, and that Y is for enterprise customers, so that the load of it is allowed, or Y is for this chart only so many jobs can be run, or some, all those configurations we provide that. So next, the services and frameworks. We started off with same single service, 2 server. Now we have an FE layer where this is basically for UI, sort of a backend for UI types. So I have subscription FE and invoice FE and multiple such things for module specific things. Then we have a business logic layer where we have a core app. This is sort of a monolith where most of our core business logic billing logic is present. Then, but we have a lot of other things like revenue analytics and integrations and other microservices. I wouldn't call it as microservices, not small things. It's thick but separate service. Then we have internal services like BizOps and audit, which is primarily used by our backend or business logic layer. The other set of services. Again, this will be HA and HAID and ELB and whatever. So this is the infra layer. Basically, these are services that help us to manage the infrastructure. Those are again services, properly API'd and everything else. These are services. So for this, we use Vertex. I don't know how many of you know about Vertex as a framework. It's we use Vertex for that. This layer is primarily built using our own framework built over just Tomcat. We are the complete. We don't use Struts or any other Spring Boot or anything else. This layer is built completely over our custom framework over Tomcat, primarily Java as of now, up till now. And this is completely serverless using Spring Boot and Lambda things. So this is the current thing. So the communication is all this. So it's all API based, not a queued system. Still just moving towards that queued system. We just whatever can be queued out. For example, audit is now completely queued. Still, most of other things are still API based ones. Some did dislike. One thing I would want to say is, in the early thing we built a sort of a model that can support dynamic environment configuration, which can be immediately updated in a second across all services. That really has helped us a lot, because you can control things based on the context. For example, you can enable something for a particular merchant or for a particular action. You can increase the timeout for a particular server at a server level. So that in production has been a great sort of a saver for us, because it helps us to sort of narrow down issues, or if one customer or one merchant has some problems, we are able to control that using that. That's one thing that is there. Second, learning, or still that we are proceeding forward, is as we add more new services and each service becomes is a different. It's not a common similar framework that we are taking and applying on every other services. We need to standardize on the infra. When I said standardize, so we use Vertex, we use Spring Boot, we use our own framework, and sometime later we might bring in something like a Python or something else. But your infra is not going to change so much. You're going to have your same monitoring systems. You want to ensure that your error handling and every other thing is still same. So I'm not talking about Dockerization or anything else. I'm talking about other systems that are there. So you need to ensure that error handling or the stack, the way you send the stack to which service you send and everything else has to be standardized. So naming conventions, you can't. It's easy to have a library to if it's in the same language, but if you're cross language, you need to ensure that some of the things are standardized. If it's domain, then the same name as domain has to be used. So those are things that learnings that is there. We want to ensure that we are working on to standardize these things so that it helps us to be more heterogeneous in terms of services. Other thing we are seriously thinking about is, it's our laptops. We have a Mac thing, and then still a lot of people lack, I think it's 2 lakh 16 GB machine, but based on the number of services that we add and everything else, it is sort of breaking. You cannot test a lot of complicated use cases from that. So as we add more services and other things, I think it makes a lot of sense for us to start thinking whether the development itself starts happening in AWS, local development, rather than in our local laptop. I think a lot of companies have started doing that. It's something that we are seriously looking at. In terms of client, we initially used the standard thing. Then we tried using Angular. I think it was just 1 or 2 UI we did using Angular. Currently, we are sort of we settled on Vue.js. We looked at React and everything else. We thought Vue.js fits more into our philosophy. There's a slight separation between JavaScript and HTML and everything else. It just has a better feel or whatever. So currently we are using Vue.js. we are phasing this out slowly to this. Again, that's something that a year later, I'm not sure what framework we might be using. Just every day you look at it as a new framework that's coming out of web. So I used to think I'm a expert in web. Now I said I don't have a clue. I just don't have a clue. In terms of deployments, right? Environments, right? So we have a we have a separate QA environment. I'll talk about it later. So this is we have multiple pre-dev environments. So the way the development happens is people develop in features, separate feature branches. Then within a team, within a module, like invoicing module or a subscription module or a gateway module, there'll be multiple features being developed separately. Then they might, once a set of features gets completed, then they might merge it into a pre-dev branch. Each team has one or more pre-devs associated with them. The pre-dev environment is where you do your UAT testing and all your basic testing, set of testings around it. That's Kubernetes and Dockerized and uses Kubernetes. So as part of it, we can, when you set it up, when you start off something, you can choose your microservices, which version you want to test against and everything else. Because if I'm developing a microservice and it interacts with an app or something else, you would need to choose you will be modifying both your microservice and other thing. So it allows you to pick your version and everything else and test it against it. So you have a environment that you think this is how it should be tested out. So all those configurations are allowed. And anytime, so whenever you start a pre-dev, the data is copied from dev to here, so that you have some data to test against and everything else. And we have, so whatever branches you picked or versions you picked, anytime you change those, things get deployed, auto deployed into pre-dev. And so feature to pre-dev, everything things are to get tested there. Then once things are finalized and everything else, then the queue starts. So we have a dev environment where it's a lot similar to production. So we haven't put yet Dockerized or installed Kubernetes in production. It's still testing out in this environment. Just that production, you need to have a lot more confidence in things around it. So dev and dev staging product, these two are very similar to production. So there's a queue. So there's a slotting mechanism where you can pick the slot. 3 days later, I'm going to release it, something like that. So pick a slot, and that slot at the time you create a release version branch, which has the latest of the dev or the master and your changes. Then you test it out in dev. Things are fine. Then you move to product staging, test it out. Then you move to production. Once it goes to production, then only we merge that branch into the master. We don't until then we don't disturb the main master branch, because you have multiple teams working on. At any point of time, you might find some issue and then get out of it. You don't want to pollute the master branch, so you try to keep it until the end and then do it. This thing is basically, this level of thing is basically for the core application. For microservices that are very thin and everything else, it's more faster. You don't need to have slots and everything else. You go in your own independent way, especially for microservices that are the edge things like BizOps or anything else. It's a faster process. You don't need to go through the slotting and other mechanisms here.
So this involves a lot of release plan.
At this stage, yes. At this stage, yes, it involves a lot of release planning. A lot of developer frustration also happens. So we do have 2 slots, so around 10 slots, right? Theoretically, it should be enough to as I told you, microservices they release on their own 10 slots. We have but somehow all customer promises Everything gets bundled into one bloody slot on a Friday or a Thursday, right? And everybody wants to jump through that. And things get escalated. Sometimes comes to me, sometimes comes to somebody else. So I think everybody knows about things. It's just that we added. See, first staging was enough. Then we realized people were. It didn't happen the first time. Okay, we didn't start off with this. We started off with staging production. It was beautiful, working well. Then we realized that if any hotfix branch comes, we are getting stuck here because there's already a branch here. So we moved out, saying that staging is should be very fast, should be always be quick. Then we put dev. Staging was only for hotfix branches. Then there was a big queue in dev, and it was like everybody complaining, saying that one team is taking up dev and then it's not releasing it, and just go through a whole thing. Hopefully, this has given us a breather. I don't know whether we'll add something more. Better thing is to microservice things out. That's the best. This is not going to scale longer term, because this queue, right? We have a sheet that is there. We haven't built a tool for that yet. So, Excel sheet. It's always filled. Like next week, people just book the slot types, and but this has helped us to reduce the queue, because from here to here, it should be done in 3 hours. That's the rule. Whatever you do, you test it, everything in pre-dev. Whatever people say it's not possible, we want to ensure that it is present in pre-dev, so that from here to here, just takes 3 hours. That's the rule. And again, Dockerization and Kubernetes has really helped us in scaling out. It's a different and CFM. It's easy to create things, replica of that. So all those technology, right? AWS has been godsend for us. So this is the tool that we built for pre-dev thing, creating pre-devs. There's another tool which allows you to create a new pre-dev and environment, test it, and specify the versioning and nothing else. We have our own, as I told you, right? We have another QA environment separately. This is again Dockerized and created, so that you will be able to run all the test cases quickly. So in an hour, we'll get all the results. Again, a complete tool. All this UI is built over using Vue.js. We're not using Circle CA or anything else, because we started off with our own tooling. Slowly built over things around that. Then we slapped a UI over it. Then we leveraged Docker and Kubernetes. So we build things around it. Maybe if you are starting now, maybe Circle CA or some other platform is a better option instead of trying to build on your own. But this has helped us to do it. And we have our own unique things like, fault, pass, failed, some test cases and everything else. Everything is possible. We're able to build a lot of things around it without having to go through tooling, logging into some things. So this is on demand. So along the path, right? One thing that we learned along it is putting a nice UI over just pure scripts. What's one is always good, because it just helps quickly in onboarding people. You don't need to script, you document it, and there's a lot of things, initial learning that period that has to happen over if you do scripts. Slapping a UI over it, even for developers, just removes one level of things. They just log in and just click something, or if you can completely automate it out like CI/CD or something, that's again better. Just having simple, we think that scripts are good. Just adds a lot of, if for doing this, do use the script. For doing that, you use the script or something, and just starts getting into your learning thing. Second thing is, it helps us to define roles, right? Only this particular person can do this type of a thing, or that's that. That's one thing interesting. Again, in terms of thing is, since if you have a lot of tools and if you have a lot of environments, right? Color coding the environment and the tools again helps. It's a simple thing, simple trick, but when you look at it, you know that person is in staging or is he doing it in dev or in pre-dev or production or something else. Where that person is, because a lot of things will be administrative tools, and you need to know the seriousness of something comes out. That thing.
So all these tools are required because you have a, let's say you had moved to Kubernetes and microservices on them. So those default toolings
Could have helped, but
a lot of investment in tooling, right? It's somewhat like non-core activity for
so for some of it, right? So for some of the tooling like this is you need to you can if you had gone to a Circle CI, maybe they would have given it. So, but not everything is just you can take it and just fit it in to your particular case. So if you use some tool, it will be a generic. For if you take AWS itself, right? Console, you have a lot of options. You don't need to do all the options. You need to ensure that there are some controls over it, and you need to focus them on particular way of doing it and coming out. If you're able to completely automate it out in the backend based on events or something else, then it's great. But once you have some interaction that has to be given, some inputs that has to be given, it helps to put a UI over it. So things like we could have, but then again you need to have a way to specify you need to choose the microservice and which version and everything else for creating a new pre-dev, right? So you need to have a UI. Maybe you can give it a script to do it, but then you got to explain the script what it is. Then you need to have a role saying that only this user is allowed to do this, right? Some cases for some pre-dev, we need to open up some port to an external customer for testing it out or something else. No, that you don't want to give it to a developer. You need to have a lead to do it and everything. So again, those complications comes, then just adds to the main thing. So yeah, it's if something is used heavily, it's not like we are immediately do a UI and then do it. Just that once we start realizing that it's being used by multiple people, then slapping a UI over it just helps. Another thing is it also forces an API mindset into the tooling itself, because if you have automation, right? For example, let's say you have an automation for on a scheduled thing, you want to upgrade or put an M update on the servers to ensure that it is on top of it. So what you will do is run a clam AV antivirus on the service, right? So those things take CPU. So you would want to remove the service from the server from the thing, and then you want to run it before you adding it back or something else. Assume that that particular thing is scheduled as when you are trying to do a build update, or something else is critical. At that time, you don't want some other service. Your two other services are also critical, and at the time you don't want the schedule. You need to have automation that is little API driven, so that you are able to check with there's some amount of sync happening in terms of it's not random scripts running different times. Hey, what happened? Oh, that's running there. So it starts putting a level of productization has to happen once it starts going to a scale. So thinking of it as just like AWS has provided an API, you need to think that as an API so that it just starts. You don't have random things running there and then people figuring out, oh, it happened because of this and that. So that also helps. So in terms of monitoring, surprisingly, we started off with Splunk. It's a costly tool, but I'm very happy we chose it at the time at the starting, because it just simplified a lot of. It's just a end-to-end tool. You have reporting, you have alerting, you have querying and everything else. It's costly, and it's when we wanted to we had to chase around the sales guy to get a license to put in production. I just thinking, man, I want to be in that situation, in that position. For a month, we literally had to call that guy up so many times, I think 10, 15 times, just to get the license to put in production. It was a $2,000 day license, a lot of money for us at the time. For them, it was like, for us, they were like, it just took time for them just to give the license. So it's so we put all things not server out is, you have that log, right? You have a complete log of files. That's not, we don't leverage that. We use Splunk for putting formatted logs where we put key value logs. So any conditions or anything else, people put kvl.put some key and value. So it's all logged in a line, which means it's like a database record. It allows you to do all sorts of queries over that. So for example, we have a record that says how many queries are hit, what's the time, and everything else around it. So we're able to put a lot of reporting queries running around it for us to get insights. So much so that we don't really log in, we don't look at our server out logs at all. So whatever it is, we stick with Splunk, and it is especially formatted. So this has been something that's been good. And it's like this is our backbone of our debugging thing. It's costly though. Just trying to look out if we can move out of this. Maybe use few of the for non-critical things. Can use some other tools or something. Datadog for, we used New Relic, little costly. Datadog is what currently using for basically JV metrics and other minor debugging. We heavily use CloudWatch, primarily for system metrics like CPU and everything else, load balancer metrics, and we push a lot of custom metrics to, like, if an error happens, we not only push it to Sentry, we also put a internal error, job error happens, we also put it to CloudWatch, number of picks, jobs picking. We push a lot of custom metrics into CloudWatch. This helps because we are able to set all the alerting mechanism and everything else. Based on some alerts, we can push it to PagerDuty for this. This combo, like Splunk to PagerDuty, CloudWatch to PagerDuty, works beautifully for us. And we use Pingdom basically for external availability checks. So there are specific URLs that we check in Pingdom that we build. We initially wrote our own sort of a code that still runs to parse error logs and sort of group them based on the same types and whatever Sentry was doing. It's doing now. We wrote it in our thing, and then it will consolidate and send mail to the team. Slowly we are replacing it with Sentry. We are deployed it for few services. Slowly we'll be replacing it with Sentry. This is another important thing that is there. From Sentry, just then Jira ticket and things. I think yeah. Thanks. Yeah.